Okay, so we're going to be practicing implicit derivatives today. Okay, so this is the second set of practice problems. So the directions say find dy over dx. So what we're going to do is we're going to start by taking the derivative of both sides with respect to x. So we're taking the derivative of both sides with respect to x. So 2x cubed, that is 6x squared, plus 3y cubed, that's going to be 9y squared, times dy over dx equals 0, because the derivative of 64 is 0. Okay, we're going to move this 6x squared over and then divide by 9y squared, so we get dy over dx equals negative 6x squared, and this is 9y squared. Then we divide both sides by the 9y squared, so we get dy over dx equals negative 2x squared over 3y squared when you finish simplifying. So just like we've been doing, to find the derivative of each one, we got to use chain rule on the y terms. Then since we're looking or solving for dy over dx, we got to get dy over dx isolated on the left, and that gives us our derivative. Okay, now on the second one, we're doing the same thing. Okay, taking the derivative with respect to x. So in the first part, I've got product rule going on because it's x cubed times y cubed. So just like what we did up there, we get 3x squared y cubed, so the derivative of the first part, plus y cubed times the derivative of y cubed, which is 3y squared, dy over dx. So that's the first part, minus the derivative of y, which is dy over dx, equals, and the derivative of x, which is 1. So now what we do is we move any term that doesn't have a dy over dx in it, we move it to the right hand side. So we're moving this over to the right side. So we get 3x cubed y squared dy over dx minus dy over dx equals 1 minus 3x squared y cubed. Now, since both of my terms have dy over dx, since I have this in both terms here, I'm going to factor it out. So I get dy over dx, and I'm left with, in the first term, the 3x cubed y squared, and minus 1 in the other one. Remember, we're trying to get dy over dx by itself, so we're going to divide by all of this. So our final answer is dy over dx equals 1 minus 3x squared y cubed over 3x cubed y squared minus 1. And that is our final derivative, dy over dx by itself. Okay? So in this one, we actually had two terms, which means we had to factor out the dy over dx right here, and then divide by that whole amount to get dy over dx by itself. Okay, so let's do one with trig in it. So 4 cosine x sine y. So again, I've got product rule going on here. So now the 4, you could do it either way. I'm going to keep the 4 with the cosine x to keep it easy. So the derivative of cosine x is negative sine x. So you get negative 4 sine x times sine y plus 4 cosine x times the derivative of sine y is going to be dy over dx, that's the derivative of the inside, times the derivative of sine, which is cosine y, equals, and the derivative of 1 is 0. So in this case, we only have one dy over dx. So we're going to move this to the other side. So we get 4 cosine x cosine y dy over dx equals 4 sine x sine y, and then we divide both sides by this, and we get dy over dx equals 4 sine x sine y over 4 cosine x cosine y. And if you want to simplify it, that would be awesome. So you get dx or dy over dx. 4 divided by 4 is 1. So you get 1 here and 1 here. And then you have sine divided by cosine, sine divided by cosine. Sine divided by cosine is tangent. So technically, you get tangent x times tangent y, because you can split this up as 4 over 4 times sine x over sine x times, cosine x, and then sine y over sine y. So this would be your final simplified, if you didn't want to stop it there. Okay, but I mean technically once you get dy over dx by itself, you could have left it like this: 4 sine x sine y, 4 cosine x cosine y. It depends on what you're going to be using it for. This, if you're going to be plugging in points, sometimes it's easier to have as tangent. Unless you only remember your sine and cosine values, then you should leave it as sine cosine. All right, and then the last one, find the slope of the curve at the given point. Okay, so again, slope is nothing more than the derivative. Okay, especially if it says find the slope at a point, then you have to do it implicitly. So we take the derivative of x to the 2/3, so it's 2 over 3 x to the negative 1/3, because you bring the 2/3 out front, subtract 1, plus do the same thing for the y, so you get 2/3 y to the negative 1/3 times dy over dx equals 0. Okay, so basically you end up with the same thing for both the x term and the y term, but you have extra dy over dx there. Next, like I said, you get dy over dx by itself. Okay, so we're going to move the 2/3 x to the negative 1/3 power to the other side. So I'm going to rewrite it as 2/3, and this is the cube root of y, dy over dx equals negative 2/3 cube root of x. You'll see why in just a minute. Then I'm going to divide both sides by 2/3 cube root of y. There should be 1 over there. There should be 1 over. And so you get this side, dy over dx equals negative 2/3 1 over cube root of x over 2/3 1 over the cube root of y, like that. 2/3 divided by 2/3 is 1, so you get negative, and dividing by something is the same thing as multiplying by its reciprocal, so you get the cube root of y over the cube root of x. That is your final derivative. Because taking 1 over the cube root of x and then you multiply it by the cube root of y over 1, that's what you get. So dy, the derivative at the point 8, 1. So we're going to plug in 8 for x and 1 for y. So you get negative the cube root of 1 over the cube root of 8. And the cube root of 1 is 1 and the cube root of 8 is 2. So you get negative 1/2. And that's your answer. Okay. So what we're going to be doing soon is using the implicit derivative, plugging in values and finding the slope of the curve, or finding the equation of the tangent line, or even we could have set the derivative equal to 0 and found where it was equal to 0 or it was undefined, and also find the critical points. Okay, so we're going to be doing all of those things that we've been doing for the regular derivatives, but now implicitly.